Okay, we were doing sex determination and we were solving this Punnett square, right? Okay, so when this x with x, small b, she would be a girl or a daughter, but she would be color blind, right? So it means that this girl is blind because not because of the only the mother, the x that is contributed by the mother is small b, and the x that is contributed by the father is also carrying in a small b. So this is both the x small b and small b, the recessive alleles, when combined together, they have produced a daughter, and she was colorblind, right? Now let's see the next one. So this is the x small b, right? And y. This boy is colorblind, but he's not colorblind because of the father, right? Why? Because the father will never contribute an X chromosome carrying a recessive allele to the sons. It is always the mother who contributes an X chromosome with the recessive allele to her son, right? So is that clear?
Yes.
Okay. Next. So this is another way to show that the color blindness, how it is inherited. There are so many other diseases that are inherited by the X chromosome. So they have given us a question here. Let's solve this. A man who is take out a register, right? A man who is red-green color blind marries a woman with normal color vision, right? The women is normal. They have three sons and two daughters in their life. One of the son is red-green colorblind. All the other children have normal color vision. Draw a genetic diagram to suggest an explanation for this. So, what should be the genotype of the father and mother? That is, father is XY and the mother is XX, right? They had four children and five children, three sons and two daughters, and one of the son is colorblind. Why? The son is colorblind because of the mother. So it means that the mother must had one recessive allele. Mother herself was not colorblind, so she would be the carrier. And what about the father? Was he colorblind? A red green eye colorblind man. Yes, he was colorblind. So he would have a small b, and on Y chromosome, there will never be an allele present, right? Because Y is a small chromosome. Now, make a Punnett square, right? For this kind of genotype of the parents, that the father is colorblind and the mother is not colorblind. Let's have a look. Let me. I'm using this space just to make the Punnett square. Okay, this was the first example that we did, and the second example. So the father was X small b, Y, and the mother was X capital B and X small b. Just two types of gametes by the father, that is X small b and Y, and two types of gametes by mother, X, right? X capital B and small b. Just make a Punnett square to show that why a son could have a color blindness. Have color blindness, right? This is the daughter carrier. This is the son, but not colorblind, right? This is daughter with color blindness, right? And this is a son with color blindness because he now had a recessive allele in him, right? So this is why there some children were not colorblind and some children were the son was colorblind because of the mother contributed a small recessive allele to the son, right? So let's see the next question. What is the chance that the couple's next child will be colorblind? With the same Punnett square, you can tell that what is the chances that their next children or any daughter or son, they could be colorblind. There are 50% chances. There are 50% because there are 50% chances for their children to be colorblind, and 50% chances are there for their children to be normal for color vision, right? So this is uh, mm, some unique examples for color blindness, or you can say the X-linked characteristics. There are so many other diseases just because that the Y chromosome does not carry an allele for the genes or alleles that are present on X chromosome. These diseases are more common in men as compared to the women, but they are never transferred from the father to the son. Is that clear? I have explained it to you with the help of some of the examples so that you can get them easily, right? Okay, now let's move on. So we are done with the chapter. Now we are supposed to start with the next topic, that is genes and protein synthesis.